Assalamu alaikum. I've built a free AI translated Islamic corpus of over 5,000 books at Nadwa.ai. And today is a bit of a nerdy topic. How have we used AI to translate this massive corpus? And what are all of the steps, quality controls, and inputs and outputs? We're going to compare the quality of the major large language models out there for translation on a specific passage, and we'll explain the features that we've developed so far. So the example is the hadith that every student of Islam has heard probably more than once. Their teacher had recited it to them as the first hadith they heard from that teacher, and it goes back all the way to the Prophet ﷺ as the hadith al-musalsal bil-awwaliyah, and it goes الراحمون يرحمهم الرحمن ارحموا من في الأرض يرحمكم من في السماء. Those who show mercy will be shown mercy by the Most Merciful. Show mercy to those on earth, and the one in heaven will show mercy to you. Take a look at this diagram. This is the software through which that passage will be run. And we'll also throw in a few more challenging passages to see how each LLM performs. Now, before the text reaches the text splitting phase, there are two optional pre-processing steps that we can do. There's punctuation addition and diacritical mark restoration. Classical Arabic was written without either of these, and a text without tashkil can be more challenging to follow along. Simply put, there's no way to tell qutila from qatala, the passive from the active form of the same word, without these diacritic marks or some experience in the language. So we've built both of these modules, and the problem we have, and the reason actually they're not implemented in the pipeline as an active stage, is because all the large language models that we're using perform more reliably without these in place. And the reason for that is that these punctuation and diacritic addition models are not as nuanced as large language models. They have far fewer parameters and run very, very fast, frequently making mistakes. So while these steps are built, I'm hopeful that a better model will be created and we can add these steps back in the future, just allowing readers to keep up with the large language models. So when that's done, the text moves on to the splitting phase, and we have three ways to split a text into processable chunk-sized bits. The pipeline runs a standalone AI model to identify meaning-based fracture points, something that could be interpreted as a paragraph boundary, a sentence break, or even a shift in meaning. We'll also split up a paragraph by punctuation if it's already there in the Shamila corpus, things like periods, commas, and open quotes. But if neither of those work, we have the undesirable method of naive splitting, which will split at a nearest maximum chunk size. That doesn't happen very often, but it does need to be there because we're limited in GPU memory available. If you want to help with that problem, check out our LaunchGood linked below. The text now enters the translation engine. And this is where I want to show you something that took months to calibrate. The system doesn't just send raw text to any model. It constructs a prompt which tells the model the kind of text it's trying to handle, whether that be a matan of a hadith or tafsir commentary or even just general narrative prose. And by including this context, the preceding paragraphs of any book, it allows the model to make a decision on contextual nuance. Take the word sheikh, for example. In ordinary Arabic, this is an honorific, something positive. But in the science of hadith literature, rijal, the grading of narrators, this is actually denoting a narrator at best of middling reliability, a tier above the bottom, below thiqa, below saduq. So a model without contextual framing will produce a translation that could be the opposite of the intended meaning. The prompt architecture solves some of these concerns. It also includes some housekeeping variables like schema and some technical details. Now, what we want to do is actually push this hadith through a bunch of different models. So with the same hadith, we ran this text, الراحمون يرحمهم الرحمن, through 7 different models. Take a look at all the outputs on the screen here. We're going to start from the worst and work our way up. The DeepSeek 8 billion model, and let me pause here and explain the concept. It refers to the number of trained parameters within the model. The larger this number, the more nuance a model can capture. Basically, the larger the better. DeepSeek 8 billion translates this quite poorly, saying, "The merciful are shown mercy. Show mercy to those on earth, and you will be shown mercy from above." It's functional, but notice what's been dropped, Ar-Rahman. The divine name Ar-Rahman is completely gone. But jumping from 8 billion to 32 billion shows a huge improvement. Reading, the merciful will be shown mercy by the most merciful. Show mercy to those on earth, and he who is in heaven will be merciful to you. So here we've had the name preserved, the meaning is intact, and the construction is generally correct. However, there's a stylistic problem here. He who is in heaven is slightly awkward. So it's accurate, but just not very elegant. Jumping up then to DeepSeek 70 billion, we'll see an even better translation. Those who show mercy will be shown mercy by the most merciful. Have mercy on those who are on earth, and those in heaven will have mercy on you. This is the cleanest syntax. It's got the best preservation of meaning, but it made a mistake by rendering men fis sama as a plural instead of a singular. And so it highlights one of the key problems of large language models, and that is inconsistent output. Running the same command through the same model can result in different outputs. Now let's take a look at Translate Gemma. This is a new model. It was just released in January of 2026, and its parameter size is 27 billion. On this same text, it reads, those who show mercy will be shown mercy by the most merciful. Show mercy to those on earth, and the one in heaven will show mercy to you. The singular is preserved, the divine name is correct, the syntax is natural. So for a model running at a fraction of the parameter count of 70 billion, this is quite good. And I want to include, just as a negative example, Translate Gemma 4 billion. It still holds up surprisingly well, saying, those who are merciful will be shown mercy by the most merciful. Show mercy to those on earth, and he will show mercy to you from above. So it's lost some of the meaning of men fis sama, echoing a similar difficulty as the 8 billion DeepSeek model, yet again, being half the size is still an impressive result. We've got a few other translations you can just read on screen by pausing the video, but let's move on to some of the harder texts. We're going to use the Quranic verse from Surah Hud, ayah 44, about the flood, where Allah subhanahu wa ta'ala says, وَقِيلَ يَا أَرْضُ بَلَعِي مَاءَكِ وَيَا سَمَاءُ أَقْلِعِي وَغِيضَ الْمَاءُ وَقُضِيَ الْأَمْرُ وَاسْتَوَتْ عَلَى الْجُودِ وَقِيلَ بُعْدًا لِلْقَوْمِ الظَّالِمِينَ. Listen to DeepSeek 8 billion's translation. O earth, bring forth your waters. O sky, lift up your clouds. And we should just stop there because that's the opposite of what the meaning is. And as we expect, a model of this size is not very performant. Moving on to DeepSeek 32 billion, which corrects that saying, O earth, swallow your water, and names Mount Judi as the ark's resting place. Let's take a look then at Facebook's purpose-built translation model, No Language Left Behind. NLLB here fails in a particular way that I want you to notice. It says instead of Mount Judi, it says House of Judah. So that's not just a mistranslation, that's identifying the geographic location incorrectly. And if you recall, on the Mercy Hadith, NLLB also failed spectacularly. For our use cases, it's not a good model. Moving on to Translate Gemma 27 billion, which states, and it was said, O earth, swallow up your water, and O sky, cease raining. Then the water receded, and the matter was concluded, and the ark came to rest on Mount Judi, and it was said, away with the wrongdoers. Here we see the commands are correct, the proper location is identified as Judi, and even though the ark wasn't explicitly mentioned in the verse, the translator added that in, clarifying what the pronoun was referring to. Taking a look at the results on screen, you'll note that Translate Gemma 4 billion also falls for the Judea failure mode, incorrectly identifying Mount Judi. And finally, we've got a line of poetry, and classical poetry is an essential part of Islamic translation. For example, the Sirat of Ibn Ishaq is filled with poetry. So we have a very simple line of poetry, nothing with too much imagery, but it is important to test out this mode as well. The line of poetry is إِذَا غَامَرْتَ فِي شَرَفٍ مَرُومٍ فَلَا تَقْنَعْ بِمَا دُونَ النُّجُومِ. And here, the DeepSeek 8 billion model translate, if you have lost your noble honor, instead of if you seek glory and high renown. In comparison, Translate Gemma 27 billion states, if you seek glory and high renown, then do not settle for anything less than the stars. By far the best rendering across all 7 models, whose results you can see on screen now. So overall, where does that leave us? Well, DeepSeek 70 billion is the strongest model on a ton of tasks. It has that style sensitivity, it has accuracy, but on our current hardware, this model runs at about a 50th of the 32 billion model speed because it's falling back to CPU-bound RAM as opposed to GPU memory. What that means then is the corpus we have online would have taken decades to translate instead of months. The translation we have online is the output of DeepSeek's 32 billion model. It's about 4 to 5 months of 24/7 AI running on a computer on top of the bookshelf right behind me. And I'd put the quality at about 85% of our quality ceiling. What that means is we have room for improvement. So locally, after Translate Gemma came out, we've shifted our workflow along with some feature improvements to include Translate Gemma, and we're seeing quality closer to around 95%. Translate Gemma 27 billion is the real winner here. It outputs at a reasonable speed with parameter counts much less than 70 billion, allowing us to fit more into our GPU memory, and it matches or outperforms DeepSeek's 32 billion model, both in terms of accuracy and eloquence. Next, let me explain why all of this runs locally. Every translation you're seeing on Nadwa.ai is generated by a model running on my single machine right there. And it's not routed through an external API. And here's the thing, the cost difference at scale is not marginal. If we sent every passage through a commercial API at the current rates, the bill for the existing corpus alone would run well into the tens of thousands of dollars. And that's per run. What you see online has been translated many times over. And every time we retranslate to improve quality, that cost has to repeat. And speed isn't much better. Running locally, the marginal cost of retranslation is just electricity and time. And so both developing and running in production locally allows us to get cheaper cost, more control, and very high reliability. Mostly because I'm maintaining all this infrastructure and you don't have to worry about it. Now, the last step in our pipeline is the quality assurance layer. And I want to spend some time here because this is one of the key steps that ensures our high level of quality as we publish books. First, every translation, no matter what, is scored using a tool called Language Agnostic BERT Sentence Embeddings, or LABC for short. Now, that's a lot of fancy words for saying we can measure the meaning of every sentence. We can measure it in Arabic, in Urdu, in English, in the same dimensional space, and then we can compute the distance between each of these vectors. That distance calculation gives us a good approximation for how close our translations are to the original Arabic. If the score falls below our thresholds, the pipeline is forced to retranslate the same paragraph. And when we do have multiple failures, the system will automatically detect and run translation multiple times over in a sort of consensus translation approach and select the highest scoring translation. Finally, we enforce structural integrity. What that means is our output must match the valid JSON schema that we're expecting. And we're also then able to scan for signals of failure. For example, translations that are much shorter or longer than the original text, translations that contain text from languages we didn't request, or translations that contain technical artifacts. That is the pipeline that produces every single ebook. We also have a parallel word by word and audiobook generation system, and these steps take even longer than the first translation step. In terms of outputs, I mentioned that we have Word documents, and that preserves the kind of structural hierarchy that we expect in books, chapters, headings, footnotes, etc. It also produces side-by-side outputs, Arabic text rendering right to left against the translation rendering left to right. And we try to create the formatting set to publishing standards rather than just reading convenience, because for us, the goal is to expand our distribution, not just to being ebooks, but also physical handheld books. In the meantime, take a listen to the sample of our audiobook.
And say as your father Adam said, "Our Lord, we have wronged ourselves. If you do not forgive us and have mercy on us, we will surely be among the losers."
The text-to-speech engine is almost indistinguishable from a human. What you're hearing is not robotic recitation, and we can do this across multiple languages. This is perfect for folks that are too busy to read a book, or folks that are visually impaired, or students that need to learn orally rather than visually. I want to be direct about where things stand with our translation quality right now. What you're seeing online is about 85%, as I've mentioned. In the next few months, you guys will see the quality of translation on Nadwa.ai go up significantly as we push translations from better, newer, state-of-the-art models. But a key part of that is your support on our launch good. If we want this translation to be textually grounded, we need your support. We need those commercial GPUs. Just one of those is going to change the game for us by allowing us to incorporate Lisan al-Arab, Lane's lexicon, and the classical Arabic dictionaries with every single word we translate. Follow the link on your screen for more. In the next video, we'll explore the Greco-Arabic translation movement with specific examples of books from Harun al-Rashid, from al-Ma'mun, and other caliphs. We'll see firsthand how the Muslims contributed towards the Renaissance and even to modern mathematics. If that's interesting for you, hit subscribe and I'll see you in the next one. Jazakumullahu khairan. Wassalamu alaikum wa rahmatullahi wa barakatuh.